In today's lesson, I will show you how to solve polynomial equation algebraically, and I want to demonstrate how you can use the algebraic theorems to solve the polynomial equation. So to solve this equation, we first need to rewrite it in the standard form so that there's only 0 on the left. So what I've just done is to move the negative s raised to the power of 3 to the left, so it becomes positive. And I also move the positive 3x to the left, and it will become negative. So the first thing that we want to do here now, after we rewrite the equation, is to apply the fundamental theorems of algebra. So the fundamental theorems of algebra tells us that the number of solutions that this equation is going to have will be 4, because 4 is the highest exponent, which is the degree of the polynomial. So the second thing that we want to apply here will be the rational root theorem. So the rational root theorem says that all the possible rational roots of a polynomial equation can be written as the factors of the constant term divided by the factors of the leading coefficient. So in this case, our constant term is 6. So the factors of 6 are plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Then we divide that with the leading coefficient, and in this case our leading coefficient is a 1. All the possible rational roots are plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. So those are all our possible rational roots. And rational just means that it is either a whole number or it can be written in a fractional form. Okay. So the third thing that we need to apply will be the remainder theorem. So the remainder theorem says that if we have a R that is a root or that is a solution of a particular equation or function, whenever f of R is 0, that means the the R is a solution. So the R will be the root of the equation. So we need to find out the root or the solution out of all these rational roots that are actual roots of the equation. So normally let's start with positive 1. So let's try positive 1 first. So what we need to do is to substitute positive 1 into our equation and see what we find. So it's going to be 1 to the power of 4. So whenever I see x, I'm just replacing the x with a 1, okay? And see the way I'm using my parentheses. So that gives us 0, okay? So this is telling me that x equals to 1 is a root of this equation. So x equals to 1 is a root of the equation. So meaning that x minus 1 is a factor of the equation. So let's now try negative 1. So if you do that, you are going to get 4. So negative 1 is not a root in this case because it doesn't give us 0. Okay, let's try positive 2. So let's try positive 2. You know that also gives you a 4. So that is also not a root. So let's try negative 2. So this gives us a 0. So that means negative 2 is also a root of this equation. So far, we have been able to find that s equals to positive 1 and s equals to negative 2 are roots of this equation. So I'm going to stop. I'm not going to continue to do the 3 and the 6 because right now we've already found 2. We are looking for 4 solutions in total. And you also have to still remember that rational root theorem is not going to give you the rational root. So the next thing that we are going to do is synthetic division. So we are going to do this synthetic division 2 times. And we are going to first apply s equals to 1, the rule to divide. So let's do it. So for the coefficient in this equation, we have 1, then we have positive 1, we have negative 5, we have negative 3, and we have positive 6. So I'm going to write them 1, 1, negative 5, negative 3, and positive 6. So how we do the synthetic division is the first coefficient, you move it down, then you multiply across the diagonal. Okay, so 1 multiplied by 1 will be 1. Then you add 1 plus 1 will be 2. 1 multiplied by 2 is 2. 2 plus negative 5 will be negative 3. 1 multiplied by negative 3 will be negative 3. Negative 3 plus negative 3 will be negative 6. 1 multiplied by negative 6 will be negative 6. Negative 6 plus 6 will be 0. So these are coefficients of x raised to the power of 4, x raised to the power of 3, x raised to the power of 2, x raised to the just x raised to the power of 1, and the constant term, which is the x raised to the power of 0. So after the syntactic division, this will decrease, the degree or the exponent will reduce by 1. So this will become x raised to the power of 3, x raised to the power of 2, x raised to the power of 1, and then this will be the constant term, x raised to the power of 0. Okay, so the solution after we've performed this synthetic division will be x raised to the power of 3 plus 2x squared minus 3x minus 6. So we are going to apply the second root, which is a negative 2. So we just do the same thing that we've done before. So we just put all the coefficients now inside there. So 1, 2, negative 3, negative 6. Okay. So we are going to bring the 1 down again, multiply. So that goes to 0. That will be 0. When we add them together, that will be negative 3. And that will be positive 6. And that goes to 0. So at the end of the day, again, this will decrease again by 1. So this is going to be x squared, x raised to the power of 0. So you can see that the x has no coefficient. The coefficient is 0. So there is no term for x. So the answer that we get here will be x squared minus 3. Okay. So after the syntactic division, our solution now is s equals to 1, s equals to negative 2. Then we are left with the equation s squared minus 3 equals to 0. This is a simple quadratic equation. So we can simplify and take the square root of both sides. Okay. To solve, that becomes s squared minus 3 equals to 0. Then we add 3 to both sides. So s squared will be equal to 3. Then we take the square root. So s will be plus or minus square root of 3. Okay. So at the end of the day, the solution of the equation is s equals to 1, s equals to negative 2, and s equals to square root of 3 positive, and then negative square root of 3. So these are the 4 solutions that we are looking for. Thank you so much. Remember to subscribe.